ready? I've asked some people already some of the difficult questions that they had from the homework last week. But Tinsei and Abdullah, if you want some more, let me know. So we'll start with the review on page 325. Okay, so we'll do a review. So this is multiplying and dividing polynomials. Do you have any difficult ones? We have 17 through 21 on page 345, and 9, 23, 27, and 28 on page 347. 28, yep, got that. Everyone wants me to do that one, so that'll be the work up to that one. Anything else? No? Abdullah? Yeah? Which number? Yeah, 145. Okay, okay, fine. So let's just start. So 17 to 21. So you had. I'll just do a couple from. So let's say we do number 6, right? So number 6, we have in brackets 5x, y, z, right? And then 2x squared. No, x, y squared, z to the fourth.
Y squared, z squared. Z to the power of 4.
And z to the power of 4.
Yes.
Okay, so we're multiplying these two, right? So basically when you're multiplying, you multiply the coefficients first. So 5 times 2 is what?
10.
10, that's right. And then we do each variable. So x and x.
X squared.
X squared. Because x times x becomes x squared. Here
Y
y times y, exactly. So if there's no exponent, it's a 1. So it's 1 plus 2 is 3. So it's y 3, and then z and
That's
4.
5.
Exactly.
Five.
So this is 1 plus 4 is 5. Any questions on that? All of them are like that. Let's try the next one from here. Let's go for 14.
Minus z.
Minus z, brackets.
Times minus z. Minus 6sy.
6 what?
xy.
xy. Okay, so this one is a monomial times a monomial. This is a monomial times a binomial, right?
Yeah.
So we do multiply times each term. So negative z times negative z is what?
Is positive z squared.
That's right. The negative times negative, they cancel each other out. Or it flips signs twice. So it's even numbers, so z squared. There's 2 z's, there's a 1 here and a 1 here, so we add them. And then we do again, negative z times negative 6xy.
Plus
Yeah.
6xyz.
That's right. So negative 1 times negative 6 becomes plus 6. That's right. And then z, x, and y. So we just put them all together. And usually in convention we write them in the order they come in the alphabet. We could put z, x, y, but we just, write z, x, in that order. Okay. So I think there's not many questions about monomials and binomials. But now let's try, let's see, so you get 17 through 21. Fine. Let's look at number 17. Now we're doing binomials. So what is it? It's x.
X plus 5.
Plus 5.
Times x minus 6.
Minus 6. Okay. So when you do a binomial, it's essentially 2 of these. This binomial times binomial is 2 monomial, binomial, monomial, binomial.
Yeah.
Okay? So this is basically the same as if we did the first one, x minus 6, and then it's a plus 5, so plus 5 x minus 6. Okay? We're using the distributive property, So you see here that 5x and the 5, and it's times this and this. We could use a distributive property to put this back together to be here. Well, okay, so it's basically x times these and 5 times these. Okay, so that's basically what you're doing when you have two binomials. You're just putting it into two monomial binomial multiplications. Right? So then this we do x times x is what?
X squared.
That's right. X times minus 6.
Minus 6s.
Minus 6 is because it's 1 times minus 6, and there's an x. Okay, so that's this one. Now we go here. 5 times x
Plus 5x.
plus 5x.
Minus,
And then 5 times minus 6.
minus 30.
Minus 30. Okay? And then if we have this whole thing here, we have two common
Yes.
terms,
Yes.
right? Like terms. So we can add the like terms.
Yes.
So x squared, we only have one.
X
X
squared.
squared. But here we have minus 6
Minus
and 5, right? So minus 6 plus 5 is minus 1. So we don't write 1, so it just becomes minus x
Minus 30.
30. Alright. Do you see that? I'll take a picture of that. Okay. Set that. Okay. Newcomers, welcome. Welcome. So we'll do number 18 now.
8. This x plus y. X plus y.
X plus y times x plus y.
Plus y.
So this is the same as if I'd written x plus y in brackets and squared it.
Yes.
See that? So it'd be the same because I just multiply it by itself.
Yeah.
Okay, so sometimes you might see something like this, and you just write it twice, because it's two binomials. So again, this is as if I had x times x plus y plus y times x plus y.
Yes.
But this time I'm not going to write it out, I'm just going to go straight from here. Because we can go from each one, right?
Yes.
So we'll first do x times x.
X squared.
X squared, okay? And now x times y.
Plus xy.
Plus x, y. So this is the first, let me write numbers here. Okay, order. 1, 1, and then we'll do 2 and 2, okay? And then we'll do 3, 3, and 4, 4, okay? That's the order that we do it in. Let's say we do this one and this one, then this one and this one, and this one and this one, and this one and this one. And then are these numbers confusing?
No.
No, they're helpful.
It's okay.
Confusing? Confusing. Alright, I'll remove them. Alright, let's just keep it like that. Just wanted to show you the order. Maybe if I did like this. And this one. Okay, first. And then does that help? Is that better? Yeah. Okay. Okay. So that's how you kind of do it in your head. So we did x times x is x squared, and then x times y is xy. Now we're going to do y times x.
xy. Plus
Because, yeah, it's yx, but we can write it the same way, because 2 times 3 is the same as 3 times 2, right? So we'll just keep it xy.
xy.
Because like I said, we like to put them in order that they come in the alphabet. And then finally the y times the y, right?
Plus y.
Y squared. Do we have any like terms?
Yes.
Yes. Usually when you do binomial times binomial, and if they have the same variables, here, you will have a like term in the middle. So the standard was called like a quadratic binomial. Often you'll have like equals 0 or something like that. So this is equals, okay, and then we can add these, right? X and Y plus X and Y is what?
2xy.
2xy. So we have x squared plus 2xy plus y squared. Okay? Now, it's important to do these because we're going to be going, at some point, you'll be going backwards from here. We'll start with this, and you'll need to go to here. Okay? Usually it'll be with like an x plus a number. And then because you'll be solving, if it equals 0, what can x equal? You'll have two answers. It's called the quadratic equation. We'll get there in a little bit, but kind of seeing these patterns of these quadratics is important to kind of see in your mind. Okay, so let's do number 19.
Is z plus 9 times z minus 9.
Z plus 9 times z minus 9. Ah, I have an idea what's going to happen here. The minus and the plus of the 9, so something's going to be cancelled out.
That is good.
Alright, so first of all, do you need me to do the arrows again so you can see? Yeah, I'll do the arrows again. So first we'll do the z. Z times z, right? So that is z squared.
Yes.
Next we do z times 9.
Minus 9.
So it's minus 9, right?
Yes.
So minus 9z.
Z.
And by the way, in America they call them z's. If you say z, they'll look at you like, I stuck to it though. South African, saying z was the correct way to do it, but they didn't quite accept it. Anyway. Z just seems a bit weird, but you know, for them Z sounds weird. Okay, so then we go here, right? So we do 9 times Z,
Plus 9.
so that is plus 9, yeah, so plus 9Z,
Plus 9.
or Z. And then we do,
Minus 81.
yeah, so 9 times minus 9
Yeah.
is minus 81. Okay, and do we have any like terms? Yes? The Z and the Z. So minus 9 and plus 9,
0.
0. So they cancel each other out. So we're just left with z squared minus 81. Okay. Good. Any questions on these so far? This is the method you use. You just kind of go this one, 1, 2, this one, 1, 2. Every single one is like that. But I'll do the other two that were requested. So let's see here. I'll do number 20. What's number 20? Ah, a bit more complex. YZ squared plus x times
YZ squared
YZ squared
minus 3x.
minus 3x.
Yes.
Okay, same idea. Lines, just consistent here. So we do this one first. Right? So y squared, no sorry, y z squared times y z squared equals what?
Y squared is the whole.
Yeah. Because this is the same as y z squared y z squared, right? Which when we do that, we're going to add the exponents. And if there's no exponent, it's a 1. So this becomes y squared. And z is 4. 2 plus 2 is 4. Z is 4. Okay, then we do the next one. Same front to here. And now it's yz squared minus 3x.
Minus 3x y z squared.
So minus 3x y and z squared. Because they're under the same variables, we just mix it and multiply them. This is a 1 and that's a minus 3. Okay, I realize. So face this thing here. Alright, so then next we will do this one. that becomes
plus
x times y times z squared, right?
yes
Plus
plus
1 and 1,
x
so
y
plus
z squared.
x, y,
Z
z
squared.
squared.
Yes.
And the final one
Minus
is from here.
x 3x squared.
Yeah, so it's a 1 and a minus 3 becomes minus 3,
Yes.
right? 1 times minus 3. And x times x,
That's 3x squared.
3x squared. Okay. Do we have any common terms, like
Yes.
terms?
Yes.
Right? The x, y, z squared. So we can add these two together.
Yeah.
So here is minus 3 as the coefficient, and here's nothing, so it's a 1.
Minus 2.
So that's right. Minus 3 plus 1 becomes minus 2.
Yes.
So this stays
Y is equal to
4 minus 2 x,
x y
y,
is
z squared
squared
minus 3.
x squared.
There we go. Any questions on that? No? Alright. Yeah? Let's do number 21. Great. Alright. 21. What is 21?
3x plus 3
3x plus 3
times
times
3x plus 5.
3x plus 5. Alright. Same idea. So first we'll do this one. Alright? What's 3x times 3x?
9x squared.
9x squared. Because 3 times 3 is 9. And x times x is x squared. So 9x squared. Next, we do the same one. And this. What's 3x times 5?
Plus 15x.
Plus 15x. That's right. 3 times 5 is 15, and there's no variable, so it stays there. X. X times 1 is x. Alright. Then we do this one. What is 3 times 3x?
Plus 9x.
Not squared. Because there's no x here. So it's 3 times 3x. That's what could be confusing. There's 3x here, but this becomes plus 9x.
Yes.
And the final one,
Plus 15.
yeah, 3 times 5 plus 15. Okay. And then we can add like terms. It's x and x, right?
Yes.
So this becomes 9x squared.
Plus 24x.
That's right. 15 plus 9 is 24. 24x
Plus
plus
15.
15. Yeah.
24x squared.
No, x. Because this is plus. X plus x. When we add terms, we don't increase the powers. When we multiply terms, we increase the powers. So 15x plus 9x equals 24x. 15x times 9x equals 9 times 15, which is 90 plus 135
And x squared.
x squared. And multiply everything. So that's why if you're adding them, the variable stays the same. You're only adding the coefficients. Right? When you multiply it, you multiply the coefficients and the variable number gets added. Okay, the powers get added. And the coefficients get multiplied. Here, the coefficients get added and the powers stay the same. Okay? That's an important, I'm really glad you brought that up. It's important, it could be confusion. So it's very important to see this difference. We start here by multiplying, but then once we have our results from multiplying, then we add all the terms up, and any like terms we add together. Alright, any more questions on this problem? there any more questions from page 45? I'll do number 26 because it's a whole problem. The other two are about the same sort of thing. Yeah, I'll do number 26. Pardon?
No, it's the same.
It's the same, but let me just do the word problem in case it's a challenge. Alright, so it says here Martha has 2 p-squared board games and John has 6 p-squared board games. Which of the following expressions represents the product of number of board games Martha and John have? Oh, okay, that's pretty easy. Let's just multiply. Alright, 26.
Yes.
Martha
2pc squared.
Equals 2pc squared.
John
John
6p squared c.
6p squared c. And all you need to remember is product is a multiplier. Alright? So product multiply. Therefore, it's 2pc squared times 6p squared c. Let me just multiply. So 2 times 6 is 12. P times p squared.
p cubed.
P cubed, because we add the exponents. And c squared times c. Also c cubed, because we add the exponents. 2 plus 1 here. Alright, so 3p. And the exponent
D.
Alright. Any other questions from page 345? No? So I think you guys got this. Understand how this works? It's good to practice. It's good practice. Put it? 27? Okay, I'll do number 27. 27. What is it? 4ab.
4ab
Plus
times
2.
Times 3ab minus 7.
Minus 7. So it's the same method.
Yeah.
Do the arrows so you can follow it. And I'll give you the, I think it's good to see this because this will be a hint for these kind of questions for the exam as well. So first of all we do this. Right, so what's 4ab times 3ab?
1a squared b squared.
That's right, so we multiply the coefficient and that's 12. And a times a becomes a squared. And b times b is b squared. Okay, then the next one.
Minus 28. Minus 20.
Yeah.
Minus 8, 28.
So 4 times minus 7 is minus 28.
AB.
This is the variable, so we just keep these ones. Okay. Now this one.
Plus.
Yep. Plus.
6 AB.
2 times 3 is 6. And there's no variables here, so it's just the A and the B. And finally, it's 2 constants multiplying each other.
14.
So 2 times minus 7.
Minus 14.
Minus 14. Oh. I want to be black. Minus 14. Okay, and we have here like these two like terms.
Yes.
So we need to add it. So minus 28 plus 6.
Minus 22.
Minus 22. So difference. So 28 minus 6 is 22.
Yes.
That's negative, so it's that one. So we have 12a squared b squared minus 22 minus 14. Okay. And that is.
Yes.
Okay. Now, I could have found the answer to this question quicker than what I did. Because you have a multiple choice, right? So if I look at this problem, I see we have AB and constant, right? AB and constant. So I know that the first term here and the last term here are going to be the same. Right? Maybe in the middle something's going to happen.
Yes.
But the first and the last will be the same. And I also know the first is these two multiplied by each other, and the last is these two multiplied by each other. So all I need to do to find from here is I say the first two multiplied by each other is 12a squared b squared, and the last two multiplied by each other is 2 times minus 7 minus 14. So I just need to find the answer that has 12a squared b squared and minus 14. And if there's only one that has that, and I look here, first immediately I put d off. It's only b and c. So then 12a squared b squared, right? And then b has minus 14, which is good, and c has plus 14, which is wrong. So I know it's b. I wouldn't have to do more work than that. So that's one way if you want to like go a bit faster. Now, that's the test taking tip. The practice tip, go through the steps so you know for sure what you're doing. Okay, and just sort of, I want to take opportunities to give you the test tips as well when they happen. Okay, is there any question on that? You asked me to go over that. No, is that clear?
It's okay.
Yeah, okay, good. Let's take a picture of that and we'll go on to the next one, division. Page 347. Okay, and we have number 9. What are the first ones to do? Let's do that.
Number 9 is 48.
48x
Plus 32y
32y
over divided by 32.
divided by 32. Okay. So here we're going to need to basically divide 32 into each of these, right? So the easiest thing that I find for this sort of thing is, of course, here we have 32 right by itself. So often what I'll do is I'll just break the top, right? If it's a single denominator, I can break the top up into 2 fractions, right? And adding. So this becomes 48x over 32 plus, there's a plus here, 32y over 32. Okay? And then we can simplify, right? This one, 32 and 32, they cancel each other out, it becomes 1. And here we need to find what are common numbers.
8.
Right? So we could do an 8. There actually will be a higher one, but we can do 8. We can start. So 8 goes into 32 how many times?
4.
4. 8 goes into 48 how many times?
6.
6.
Again.
And now we have a 6 and a 4. Any common numbers?
2.
It's like 2. So 2 goes into 6, 3. And here's 2. So we have 3 over 2, x.
Yes.
So this equals 3 over 2x
Plus y.
plus y. Okay, you see that? One other way that you could do it is you could keep
No.
you could keep this you could keep it over here, and then whatever you do to reduce these, you kind of do to the bottom one as well. So what I could do, I could also write it as 48x plus 32y over 32, right? And then when I did 8 here, it became 4, and I could do it to each one of these. That's one way I could do it, right? And then I could do again, this is 2, and this becomes 3 and 2. So then that equals 3x plus 2y over 2. Okay? And I can do the same thing again. It becomes 3x over 2 plus 2y over 2, which equals 3 over 2x plus y. Because sometimes it'll be more useful to have it in this format with the 2. Of course, I can always convert back from here, right? If I wanted to add these, do you remember if you're adding fractions? Like if I needed to add 1 over 2 plus 3 over 4, remember what I would do?
Yes.
I'd get a common denominator,
Yes.
right? So this would become 2 over 4 plus 3 over 4, right? And that would equal 5.
7 over 5.
5 over 4, right? Or say I have, so say here we have 3 over 2 plus 1, right? And then we could do that, we can always make 1 as a fraction of the same number over itself.
Yeah.
So that equals 3 over 2 plus 2 over 2. Right? Which then would equal, yeah, so 5 over 2. Now we could do that here. So 3 over 2x plus y is the same as 3 over 2x plus 2y over 2. Right? It's the same thing as this. And then that could give me 3x plus y over 2. Give a common denominator. Sometimes, like if I use this method, right, of cancelling it out, but I actually need to keep it in this format, because there's some ways to get to here. I could do it this way to get to here. There's different ways to get there. Object, but it's all those ways. Pardon? Yeah, you did this. Yeah, you took 8 out. That's a good point. One of the things that Samantha said she did was she actually used the distributive property to get a common number out. Alright? So this one, you could take 8 out of it. Actually, if we did 8 and then 2, so really 16 is a common number inside of them, right? So 48x plus 32y equals 16 times 3x plus 2y. Like that, right? So then we could write this as 16 3x plus 2y over 32, right? This one can become this one. And then we just do 16 and 32 becomes 1 over 2, right? So that equals 3x plus 2y, so that's a y, over 2. And you can also go from that to this. That's another way to do it, using the distributive property. You could do 8 and then do it twice, but it's easier to do, if you can see it's 16. Yeah. So you get into the right place, and it's a good way to do it. Okay? Any questions on this? Let's do the next one. That was number 9, right? Alright, so number 23, there wasn't any in between, you guys who came in. You want to do some other ones before I do number 23? Any early ones that were maybe a challenge? Oh, which one? Okay, 20. I have 28 already. Everyone has said 28, so 26. Let me just do 2 of them before I get to 23, just to make sure we're on the right track. So I'll do number 14.
Number 14.
Yeah, so number 14
is 10x squared
10x squared
plus 6x
plus 6x
over 2x.
2 over 2x. So again, there's 2 ways to do it. You can switch them into separate fractions, or you could use a distributive property. I'll do fractions first, and then I'll do distributive property. So this one equals 10x squared over 2x plus 6x over 2x. Okay, and now here, if we have an x on the bottom and x squared, the x is cancelled, right?
Yeah.
So this becomes not 1, and this becomes x.
Yes, 5.
And then 2 and 10, that's right,
5.
becomes 5.
5.
Okay, here the x is cancelled, and 2 and 6 becomes 3. So that equals 5x plus 3. Alright. Or I could do a distributive property for each of these, right, from the top here. And we can see there's a 10 and a 6, they have a common 2.
Yeah.
Right? So this equals 2, and they each have an x as well.
Yes.
So it becomes 2x
X plus 3.
5x plus 3 over 2x. And these cancel each other nicely, and we're left with the same. And that's the thing, often these problems, when they give you something like this, a variable on the bottom, you can probably guess that you can take it out of the polynomial fairly easily. Not necessarily, some of them are more difficult. So let's look at number 18 as an example. 3x plus 18 over x plus 6. Okay. Now in this one, my example, this method will not work very well for me. Okay? Because then I'll be left with 3x over x plus 6 and 18 over x plus 6. That doesn't help.
Yeah.
Alright? But if I look at this, 3x plus 18 is a common 3 in both of them, right? So let's just take the 3 out.
Yeah.
So x plus 6 all over x plus 6. So these are going to cancel each other. Right? There we go. So that equals 3. Do you guys see how the earlier work we did with fractions, how important it is now? Yeah. All the stuff we're learning with like crossing out of the common denominators. That's why it's so important to do the fractions. I feel like fractions are the foundation for like those methods. So if you're a little bit rusty on the fractions, go back and look at some of the stuff we did and look in the book and try to like make sure you're strong on that because we're starting to use all those methods. Okay. Any questions on that? Let's go on to number 23. Oh.
Yeah.
Actually, no, it's not too. Okay.
Yeah.
So 23.
X minus y.
X times y minus 2.
Minus 2, sorry, yes.
Minus 6.
Times y minus 2.
Y minus 2. And the whole thing is over y minus 2?
Yeah.
Okay, so you really can see here, they made it kind of easy for you. Y minus 2 everywhere.
Yeah.
Right? So, there's one way I could just say is I can, if I have the same term in each one up here, I can cancel out inside each one. Right? So I could write this one now my first way. I could write this equals x times y minus 2 over y minus 2 minus 6 times y minus 2 over y minus 2. Right? So that's one way I can do it. And then these cancel, and these cancel, and I get x minus 6. Okay? Or I could say, well, I see I have the same term here and here. So I can just cancel them straight out in here. But to know why I can do that is because you can write this using the inverse distributive property, and this equals x minus 6 times y minus 2 all over y minus 2. Because remember when we were doing multiplying binomials, and I said if you have something like this, it equals something like this, it equals this one times that, and this one times that.
Yeah.
So when you see this one times the same thing, and this one times the same thing, you can go backwards, right? You can write it as a binomial multiplication here. And now we have the exact same thing above and below, and these can cancel each other out, and we get x minus 6. Okay? This is one of the things I like about algebra. There's often more than one way to the same answer. And when you try it, and then you try the other way, and you get the same answer both ways, you can feel more confident about your answer. And as we'll learn today, when we do equations, when you solve for the equation, you put the number back in, you check it, and if it equals, then you know you got the right number. All right, so that's number 23. Do number 26. Okay, number 26. Word problem. Okay. James has 27 X apples, and Rachel has 51 Y apples. Glenn has 6 pieces. Represents the average number of pieces and Glenn has. All right. So do you remember how do we find an average?
Yes.
How do we find an average?
The sum of
The sum of
the numbers divided by the number of like here there are 3.
yes.
We add them and divide it by 6.
Exactly. So an average is the sum of all the numbers divided by how many numbers you have. Okay? So this average equals sum divided by number. Okay? So the sums, you add them all up, and the number is how many of them. Right? So if we have one person is 20 years old, one person is 30 years old, and one person is 40 years old, the average age for those 3 people is 20 plus 30 plus 40 divided by 3. And we know like 20, 30, 40 means it's going to be 30, right? But 20 plus 30 is 50 plus 40 is 90. 90 divided by 3 is 30. So like if you can't quite remember what an average is, remember that example. Okay? So here we have, what is this, 27 x. So the sum
Plus
is going to be plus 51 y plus 60?
600.
600. Okay. And then the number, how many terms are there?
3.
3. All right. So our average will equal 27x plus 51y plus 60z all over 3. Okay? And what's convenient is if you look at each of these numbers, they're actually divisible by 3.
Exactly.
Alright? Do you remember my trick for knowing if a number is divisible by 3? You guys remember the trick?
Yes, 9,
The trick to know it is if you add up each of the numbers here, if it equals a number that's divisible by 3, then that number is divisible by 3. So 2 plus 7 is 9. 9 is divisible by 3.
Yeah.
5 plus 1 is 6. 6 is divisible by 3.
Exactly.
6 plus 0 is 6. 6 is divisible by 3. So I know 3 goes in each of them.
Yeah.
It's a cool trick. It works for 9 too, actually.
Yes.
So this equals 3. 27 times, or what times
9x
3 equals 27? 9. That's right. So 9x plus,
17.
what times 3 equals 51?
17.
17. Alright. And what times 3 equals 60?
Plus 20.
Plus 20 z. Or z, yes. All over 3.
American system.
So I cancel it, and that equals 9x plus 17 y
plus 20.
plus 20. Any questions on that? What's that word? 17e. Okay, any questions? Good, then I'll take a picture of that and we'll do 27. Don't have any button there? No, it's not a good picture. Nope. How do I delete it? You know what? I'll just take it. Yeah. So 27. What is it? Which of the following expressions is equal to this whole long thing?
Yes. 2
Alright.
z squared
So 2z squared
minus 12z
minus 12z
plus
plus
2 times,
brackets
yes, 2 times
z
4
plus 4
minus 8.
minus 8. And all of that
That's
over 2z. Alright, you can say z. I'm going to stick to I'm going to stick to my way of saying it. Okay. I like to tell the Americans like to say, oh, we're such a big country of 300 million people speaking English, so therefore we have the right way of saying it. And I tell them, India has more than 1 billion people and they speak English and they speak it the British way. Plus there's Australia and South Africa and England and Britain, but I don't think them all together would quite make 300 million, but definitely India does, so that's it. Anyway, yeah, so the problem here is we have this long thing at the top, and it's not quite ready to divide through yet. So we need to simplify what's on top
yes.
before we do the division.
Yeah.
Okay? So I'm going to keep this here at the bottom,
Yeah.
and we'll just simplify what's on top. So we'll keep the 2z, okay? And let's see here, let's solve out what's in the bracket. So it becomes 2z squared here,
Yeah.
minus 12z,
Yeah.
and then this is 2 times z is what?
2z
Plus
2z
2z,
plus 8.
2 times 4, plus 8,
Yeah, minus
and then we do minus 8. Alright, that solved my biggest concern. Because I saw this minus 8, and I saw z down here.
Yeah.
And you're not going to be able to cancel it out, right? But now I see we're going to be able to cancel, because these will cancel each other out. So here, let's put equals here. We'll keep the 2z on the bottom for now.
Yeah.
We'll just go each step. So here, we got 2z squared.
Minus
That's right, so we have a z and a z, like terms. So minus 12 plus 2
minus 10.
becomes minus 10. Minus 10z. And 8 minus 8 is 0.
Zero.
Alright, so I don't need all that, I'll just do this one. Alright, and now we're back to the same kind of problems we've seen before, right?
Yeah.
So let's do the one where you take the common number out. Yeah. So there's a 2 and a 2 here, and a z and a z.
Yeah.
So we have 2z, and so what times
Z
2z equals z squared?
is that
Just z.
minus
Right?
5.
And then here, what times 2z equals 10? It's minus 5.
Over
All that over 2z,
Z.
cancel.
Yes. Z minus 5.
Z minus 5, which is 8. Pardon? There's 2z here. So I'm starting here, right? And I'm basically using the reverse distributive property. So what I'm saying is, when I have a polynomial, right, it's looking here, and I say I have AB minus AC, right? I see that there's an A and A in both of them.
Yes.
So the distributive property says that if you have like A, B plus C, right? This becomes AB plus AC. That's the distributive property. The reverse distributive property is to go backwards and say when I have a polynomial, I see a common multiple, common factor. When I see a common factor in each term, I can put brackets around it and like take it out. So if you remember when you're doing factors, instead of like prime number factors, like what are the factors of 12? Or there's like 2, 3, 4, and 6. Factors of 12. So you can use the concept of the factors to find out what's your common factor and take it out. So this here, this will equal A times B minus C. Right? You see they go the inverse property. So I'm doing the same here. I have a common 2, right? There's a 2 and a 10. So 2 divided by 2 is 1, and 10 divided by 2 is 5.
Right.
So now I have a common 2, and I also see here's z squared, and here's a z. So I have a common z, because z squared is z times z, and z is z times 1. So there's 2 and a z, so I can take a 2 and a z out, and then I figured out, okay, if I do that, what's left, right?
Yeah.
So if I have 2z here, what's left is z, because z times 2z equals z squared, which is z squared. And here I took a 2z out of minus 10z, which is minus 5. Because minus 5 times 2z equals minus 10. So you kind of go backwards. And that way, I can, and then when this comes out, I can just cancel them each out, because there's a 2z on top and 2z on the bottom. So something divided by itself is 1. And one hint, it's often these kind of questions, when you have something like this, and if you see 2z here, you should think maybe 2z is common. Maybe making the question so it's easy for me to cancel it out. Right? So you're like, okay, the first thing I'm going to check is if there's a common 2z. And I look, and yes, there is. This has 2z in it, and this one has 2z in it as a factor. Okay. Now for the question we've been waiting for, right? Number 28. Alright, for what values of A, especially this expression, undefined. Aha!
Yeah.
I did say undefined, what undefined is. So it's, we'll review. A times 4A
minus 16
minus 16A
all
over
yes
Ooh.
A times
A times absolute value
yes
A
plus A squared.
plus A squared. Alright. Do you remember undefined? Remember from last week what undefined meant? How we could get undefined? If you divide by 0, you try to divide by 0. If you try to divide by 0, then you shouldn't match. Right? It's you cannot divide by 0. If you divide by 0, you'll get an undefined answer. So essentially when they're asking here, this whole thing, they're asking what values of A will make you be dividing by 0. Which means you don't need to worry about the top, because if A is 0, fine. The top can be 0, but having a 0 on the top is not undefined, it's 0. The top is having 0 in the denominator. You cannot have 0 on the bottom. If 0 on the bottom, it's going to be undefined. So basically we need to know A times absolute value of A plus A squared. What values of A will give us 0? So for what values of A does A times absolute value A plus A squared equals 0? Alright, so you need to think about this, right? You remember what absolute value means?
Yes.
Yeah, it means whatever it is you take, if it's negative, it becomes positive. And if it's positive, it stays positive. Okay? It doesn't, the absolute value just makes whatever it is positive. Alright, so here we have something A times A squared plus A squared. Alright, so let's just throw some numbers in there, right? Let's say A equals 2. Alright? If A equals 2, it becomes 2 times absolute value 2 plus 2 squared, right?
Yeah.
And 2 absolute value is just 2.
Yeah.
So it becomes 2 times 2 plus 2 squared.
Yeah.
Alright? And that's 4 plus 4. Is that 0?
No.
No. Okay, so you will not get undefined. You get a real answer if A equals 2. Alright. So that's fine. You could say, well, what if we do a negative number? Because it's adding, right? So let's say negative 2. I'll put a question mark. A equals negative 2. Does that work? we can put negative 2 times absolute value negative 2 plus negative 2 squared, right? Now, absolute value of negative 2 becomes 2. So it becomes negative 2 times 2.
Yes.
And 2 squared,
Four.
negative is squaring, right? So it becomes positive. So that becomes 4. So it becomes negative 4 plus 4 equals 0. All right. So negative 2. And if you think about it, you'll see it'll work for every negative number, right? There's negative 5, it'll be negative 25 plus 25. So that means every negative number seems to be true, it'll get undefined. Every positive number, we'll get a normal answer. It won't be 0. We can see even with 1, right? Negative 1 times negative 1 will become 1 times 1, which is negative 1. Negative 1 squared will become 1. So negative 1 plus 1 is 0. So every negative number. So there's only one number left that we're not sure about, and that is 0 itself. Right? Let's try that. A equals 0. So we get 0 times absolute value 0 plus 0 squared. What does that equal? 0. Right? 0 times 0 times 0 plus 0 minus 0 divided by 0. Well, you can't divide by 0. Times 0 equals 0. So 0, yes. So basically every number that is 0 and below. Right? A equals every number that's 0 and below. So now let's look at our options. The first one says A equals 4. No. Right? 4 is a positive number. The next one says A, you see this sign? A, what does that mean? What does this mean? Smaller than? And this? Or equal? Smaller than or equal to 0. Does that describe what we've seen? Right? If it's less than 0, it's a negative number. Yeah. If it's equal to 0. So if A is less than or equal to 0, we're getting this. So it means it is this one. Yeah. Okay? Yes, this. B. Let's check the other ones just to be sure. Next one, C, A equals to C. No, it's a positive number. And D, A is greater than or equal to 0. If it's equal to 0, it will be 0. But greater than not. Right? So, that's a B. This was a challenging question. That was a very challenging question. You have to kind of like think through it. Go over it for a little bit. I'll put this in circles. Okay, so I'll write here, not positive. Yes, negative. Numbers. And yes. Okay, so this one is yes, negative numbers is less than 0. And A equals 0. So A is equal to 0, A is less than 0. Those are the times you'll get it. So A is less than or equal to 0. That's what that sign is. Are any of you unfamiliar with these greater than equal in signs? So we're going to start using them. Yeah? It's basically a sign mentions the big mouth, right? And the mouth is eating the bigger number. So the greater than is pointing towards the biggest. And then sometimes if you want to write or equal to, you put a equals underneath. It's like the one bar of equals. Alright, I'll take a picture of this. Alright, I think it's time for a break. You guys can have 5 minutes break, and then we'll come back and start our new material. Alright, so today we're going to be doing equations, which is kind of the heart of algebra. Right? I feel like finally we have arrived at algebraic equations. Are we looking forward to this day? So basically an equation is something that means it's an expression of I'll say equality. Well, that sounds like a very philosophical concept, but in mathematics it just means this equals this. Okay? So 5 equals 10 divided by 2. Right?
Nice.
Yes, we all agree with that, right? 7 times 3 equals 42 over 2.
Yes.
Do you agree with that?
Yes.
Right? Because this equals 21, and this equals 21. Right? Pardon? Okay. 7 times 3 is 21.
Yes.
Okay. 42 divided by 2 is 21. So 21 equals 21. So it's an equation. It's not, that's why it's, an equation is not just this is the answer. The equation just says whatever's on this side equals the same as what's on this side. Okay, it's like a balance. Yeah, good. So it's equal. Equation. It's the equation equal. It has the equal sign. Alright? 3 minus 12 equals 8. Equals negative 2 plus 4 minus 4. Minus 9. Minus 9. No? Yeah.
8.
Yeah. So minus 2. Okay? So 3 minus 12 is minus 9.
Minus 9.
Minus 2 plus 4 is 2. Minus 11 is minus 9. So these are equal.
Yes.
Right? This is minus 9, this is minus 9. It's an equation. Alright? This is a challenge, yes. Now I haven't even added algebra. Right? I'm just showing you equations in numbers. Right? The easy one, of course, is 3 equals 3. Right? Equation. It's all the same. Basically, whatever's on the right of the equal sign is the same as what's on the left of the equal sign. Okay? Now, in algebra, most of the time an equation takes the form of something equals 0. Okay? So, 18 divided by 2 minus 9 equals 0. Do you agree?
18?
Divide by 2 minus 9
Yes.
equals 0.
Yes.
Equals 0. Equals 0. Okay, so now, what if instead we put here that 9 equals x? Alright? So we replace 9 in here with x. So then that becomes 2x over 2 minus x equals 0. Alright? And this is true only if x equals 9. Oh, this is true only if x equals 9. Right? If x equals 8, oh no, this is actually true in all cases. I should do a different one. Let's do no way, that's not going to work for me. And this is true in all cases. So let's try let's go back to no, that's not quite working for me. For example. So this is fine. This equals 2. But let's say we do instead x equals 3, right? Then we have 3x over 2 minus 3x equals 0. Okay? And in this case, if x equals 4, it doesn't work. It doesn't equal 0, right? Because 3 times 4 is 12, and here says 3 times 4 is 12 over... No, this doesn't work either. It should be 6x, yeah. You know what? I'm doing the wrong example. We'll start with something else, and then I'll move back to that. So say we have, let's take like maybe this one, right? And we have here 7 times x equals 14, right? 7 times x equals 14. So if we have this equation right here, there's only one value of x for which it is true, right? 2, right? If x is anything other than 2, it doesn't equal 14. So it's not true. So what you're doing when you have an equation is you're solving to find what is the number that makes this one true. So if you recall, what we've been doing in algebra up until now is we've said there's this variable is this unknown number. There's an unknown number, we can do stuff with it. We can multiply it, we can simplify it, we can use it in polynomials, we can do all these things with it. But what you do with an equation is now we say, all right, now we're going to solve to figure out what that number is. And when I say it equals this, now I can solve and say, okay, I've done all these things with the unknown number, but now I can solve and say it's actually 2. The unknown number we're looking for is 2, because now I know that it has to equal 14. So say we have, if we have this one, 20 over x equals 5. X equals 4, right? These are some basic ones. How about x plus 3 equals 12? 9. It's plus, not multiplied. So it's x plus 3 equals 12, right? So that's all that's the way of doing these. So now what we have is we have a specific way of solving for x when we have equations. We'll take a picture of this. Sum this out. So what we do is when we're solving for a problem like this, we want to write it as something where we have the variable by itself on one side and a bunch of numbers on the other side. Okay? And so what we can do is we can do operations to an equation. And what's interesting with an equation is if you do something to one side and you do it to the other side, it stays equal, right? So if we take again, I said 3 equals 3, all right? Now let's say I multiply each side by 4, all right? So 3 times 4 equals 3 times 4, all right? That's to say I divide now. 3 times 4 divided by 6 equals 3 times 4 divided by 6, right? You see, whatever I do to one side, it doesn't change the fact that this equals this. Right? Let's try again this one that we had. We had, what was it, it was 3 minus 12 equals negative 2 plus 4 minus 11, right? Okay? Now let's say we add 12 to each side, right? So we can do 3 minus 12 plus 12 equals minus 2 plus 4 minus 11 plus 12. This will still equal the same, right? This will become 3, and this will become minus 2 plus 4 is 2, plus 11 plus 12 is the 1, so it'll become 3. So 3 equals 3. The value changes, right? This one is minus 9, this is minus 3. But an equation doesn't care what the value of one side equals. An equation cares that both sides are always equal. Okay, that's what matters. So this is 3 and this is 3. So the question you can have is, what do I need to add to each side to get it to 0? And this would be, for this one, it would be minus 9. Or it would be 9, right? If I added 9 to each side, so say instead, I add 9, then this will become 0 equals 0, right? Which is also an equation, which is also equal. Equal and equal. So, for example, this one I have x plus 3 equals 12, right? Now what I want in this case is I want to have x by itself on one side. So I need to do something to this side to get x by itself. In this case I have plus 3, so I need to subtract 3. Alright? So I'll do x plus 3 minus 3. However, whatever I do to one side, I have to do to the other side, right? So that becomes 12 minus 3. So x plus 3 minus 3 becomes x, and 12 minus 3 is 9. And there we have x equals 9. And that's our result. So that's how we solve equations. We try to get x by itself on one side, or y, or whatever the variable is. Usually when we're using x. Right? This one, for example, 7x equals 14. To get x by itself, what do I have to do? If I subtract x, then I'll just get x on this side. We need to divide by 7. Right? Because if I subtract x, I'll get 6x and 14 minus x. That's not really what I want. Right? We want to get x by itself. So if you have something like this, where you have just the one term and the coefficient, you divide by the coefficient to get x by itself. So this becomes, we divide, so it becomes 7x over 7 equals 14 over 7, right? Whenever we do to one side, we do to the other side. Now these cancel, so we get x, and this becomes 2, and this becomes 1, right? So x equals 2. This is what we said, right? So this is how we're solving the problem. It's really cool stuff, actually, when you're looking at it. I mean, these ones you can intuitively know, but the harder ones, you won't know, but you solve for it, and you'll see. And then what we can do afterwards, we can always plug x back in, right? So we can always say, okay, x equals 2, let me check it. 7 times 2, where the x is, equals 14. Remember when we were doing this? We said x equals this. Now we check it. 7 times 2 doesn't equal 14. So I know that x equals 2. How about this one? We have 20 over x equals 5. Okay, now I don't want an x on the bottom. I want an x on the top. That's right, so we multiply both sides by x. Okay? So 20 over x times x equals 5 times x. Okay, we multiply both sides by x. So here, this one cancels, and now we're left with, I'll move it up here, 20 equals 5x. Alright? And now we're like in this situation. Alright, so now I want x by itself. It doesn't matter which side of the equation x is. Right? 20 equals 5x is the same as 5x equals 20. If it helps you, you can just move them. It becomes 5x equals 20. You can flip. Right? And technically what you're doing is you're adding 20 to both sides and subtracting 5x. right? No, you're just switching it around. But pardon? But actually, I like to just keep them like this, just so that I stay consistent, so I know what's going on. And now I want x by itself, so I will divide by 5, right? So this becomes 20 over 5 equals 5x over 5. The 5's cancel. 5 and 20 becomes 4. So 4 equals x, or x equals 4. Okay, which is what we got here.
And so we can do 20 over x equals 1 over 5 times 1 over 5, yeah?
Yeah, so you could do it at the same stage. You could do a double step at this point. What you could do is instead of multiplying by x, you multiply everything by x over 5. And that'll give us what we want. But I like to do multiple steps just so we know what we're doing. Is that what you were saying, or were you trying to say something else?
No, I say 20 over x times 1 over 5.
Yeah, 20 over x times 1 over 5, yeah.
Times x is 5x, over 5 x is 4.
Yeah. And do you guys remember when we did the cross multiply? Remember when we were doing fractions, cross multiply? You can do that here. So we could cross these x and 5, right? We cross them, and then it becomes x equals 20 over 5. Which is what we got here. So that's one thing we can also do. If we have this one, right, it becomes 20 over x equals 5 over 1. And basically this becomes 20 over 5 equals x over 1. Remember, anything across here can be switched. So we do that, we switch the x and the 5, and then we have 20 over 5, which is 4. Now with equations, I don't do equals, because the equals is here. So often I'll do like a little 3-dot thing, which means therefore. Okay, it's like here's the result. You don't even have to, you can just go a line at a time with the equation. But if you want to do like equals, but you're like, wait, I can't do equals because the equation is equals, you can do your 3 dots. Okay? Or, the other thing, I like to keep the equal sign in a line. So as I go down the page, I can see what each side is. Keep it consistent. Otherwise, I lose where I am on each side. You can kind of keep your equals in a line down the page, and whenever you're switching or playing it on each side, you can remember you do it to the other side. Right, this is kind of a confusing board now. I'll take a picture of it then for if you want to watch the video later and see it. Let's do some more practice. Let's say, for example, you have 78x equals 6. Sorry, the other way around. 6x equals 78. How would you solve this? Divide both sides by 6, right? So what I'll often do, instead of doing just 6x over 6, I'll just kind of do it here. Like this. Alright? And so then these cancel. So it becomes x equals, if 6 goes into 78, how many times?
13.
13? Goes to 7 one time, remainder 1, and to 8 3 times, yeah. So x equals 13. This is like your single step over here. Or you can have 5 minus x equals 0. Exactly. You can see it. The way we would solve it is as I add x to each side, right? So 5 minus x plus x is x, right? So then negative x plus x becomes 5, so x equals 5. So these are the simple ones. But now what if we have a bit more complex problem, right? Multi-step ones. So say we have 3x minus 5 equals 1. 3x minus 5 equals 1. Okay? Let's solve for x. So the first thing you need to do when you have something like this is the first thing is you want to what you want to do is you first want to get rid of multiple terms, right? So you need to try to get x, whatever the term with the x is, you isolate that on one side first. Okay? So we add or subtract so we can get this term by itself. Okay? So we want to get rid of this 5 on this side. So how do we get rid of this 5?
Plus 5.
It's a minus 5, so to get rid of it, we have to add 5. So it becomes 3x minus 5 plus 5 equals 1 plus 5. Okay? Now these cancel, so we get 3x equals 6. Alright, now you can kind of see what we do, right? The next stage, now that we've gotten rid of the extra terms, we have only the x term by itself on this side. Then we can divide by the coefficient to get x by itself. Okay? So then this, we do 3x over 3 equals 6 over 3 means x equals 2. Okay? And if you're unsure, you can put it back in. 3 times 2 minus 5 equals 1. Is that correct? This is 6 minus 5 equals 1. Yes, that's correct. So that's how you know. This is basically your simple steps. And all of these equations are like this. Okay, multiple steps. First step, get rid of the extra terms, so you can have x by itself. Second step, divide by the coefficient to solve for x. Let's do a few more practice problems. Seven minus x, 7 minus 2x equals 5. This one's slightly more difficult. 7 minus 2x equals 12. So the first thing, there's two ways you can do this. Okay? One way is we just want to have this by itself. Who cares if it's negative? So we want to get rid of the 7. Right? So we subtract 7. Yeah, or you add negative 7 to each side. So this will become 7 minus 7 minus 2x. No, actually, let me keep it so it's consistent, so you know what's going on. We'll do 7 minus 2x minus 7 equals 5 minus 7. Okay? And here the 7 and this minus 7 cancel, and we get minus 2x. And here 5 minus 7? Minus 2. Okay. And now I think you know what the next step is, right? We divide each side by negative 2. So negative 2x over negative 2 equals negative 2 over negative 2. These cancel, the negatives cancel each other. This becomes a 1, so x equals 1. Okay? When we put this in, if you want to check it, 7 minus 2 times 1 equals 5. So 7 minus 2 equals 5. Yes, correct. Is this clear? You see what I did here? I'll do another one so we can follow. Okay? Let's say we have.
It's the same.
Pardon?
I did 7 minus 2x is equals to 5. 7, yeah.
So what
Minus 2x is equals to 5 minus 7.
Yeah, so what I can also do.
Over minus 2, over minus 2 and x is over minus 2x is x is equals to 1.
Yeah.
It's the same. It's okay.
If you did minus 5,
No, if 7 I take to 5.
what do you put to here?
7.
Yeah, that's what you're doing here. You're putting 7 here. Minus 7 minus 7.
Okay.
One thing you can do is you can say, I don't like this negative here.
Sure, 2 times 7.
Pardon?
7 minus 2x times 7.
No, it's minus. Sorry.
Okay.
Wasn't clear. It's a minus sign. Yeah, you're right. It looked a bit like a sign. It's subtract, because I'm wanting to get rid of my constant here. I want to have only the x term on this side. So I subtract the 7. Say, for example, it was this. Say it was 7 plus 3x equals 5. Okay? The same idea. I subtract 7 again. No, wait, equals minus 5. Right? Let's say it's this.
Minus 5.
So we're going to subtract 7 from each side, right? So it becomes 3x equals negative 5 minus 7. Okay? I subtract the 7. I often see it as like moving it to this side and changing the side. But you have to keep in mind what you're actually doing is subtracting from both sides. Okay? So now we have 3x equals negative 12. Okay? And then we divide both sides here by this constant, by this coefficient, sorry. So divide by 3, divide by 3, and then x equals, what's minus 12 divided by 3?
Minus 4.
Minus 4. Okay, we can check this one here. 7 plus 3 is minus 4 equals 5. 3 times minus 4 is 12, so 7 minus 12 equals 5. Oh, it's minus. That's correct. Any questions? I'll do some more examples. Just want to make sure you guys are following how we do this. You have subtract and add to each side. You can multiply, divide on each side. The only thing is, whatever you do to one side, you have to do to the other. And the technique is almost always you find your term with your x, and you find what do I have to do to this side to have this term by itself. Right? So I have to here I have to get rid of the 7, so I subtract the 7. Here also I have to get rid of the 7, so I subtract the 7. And now once I have the term, which includes its coefficient by itself, then I want just the variable. So how do I get rid of the variable? I either add or divide. So I multiply or divide to get rid of the variable. So the next one I'll do is one with a fraction. So how about we have x over 3 minus 4 equals 2.
Multiply by 4.
First we want to get rid of this, right? We want just the term here. So we'll add 4 to both sides. So x minus 3 minus 4 is plus 4 is 0, and then 2 plus 4. Okay, we added 4 to both sides. Now, so that means x over 3 equals 6. Alright? Now we want x by itself. Right? So we have this 3 here. So how do we get rid of that? We multiply each side by 3. Okay? So multiply by 3, multiply by 3. So that's x equals 6 times 3 is 18. You see that? And we can check it. Over 3 minus 4 equals 2. Divided by 3 is 6. Minus 4 equals 2. Check. You got it right. What happens when we have multiple x's? Right? Let's say we have 3x minus 5 equals 2x plus 7. Now what are we going to do? Because we have x's on both sides.
One side and numbers.
Yes. So we want to get x's, all the x terms on one side, and all the constant terms on the other side. Okay? So I'll do it step at a time, but usually you can do this in the same step. So we have 3x and 2x. I'd rather have positive, so I'm going to get rid of this 2x. So how do I get rid of this 2x? I subtract 2x, right? So this becomes 3x minus 5 minus 2x equals 2x plus 7 minus 2x, okay? So these cancel, and we get 3x minus 2x is x. X minus 5 equals, these are out, equals 7. Alright? So essentially what I've done is remove this 2x to this side. Right? Now I need to move this 5 to this side. So to get rid of this 5, I add. Right? So it becomes x equals 7 plus 5. And I add 5 here, gets rid of it, and I add 5 here. So then x equals 12. Okay? And we can check it. 3 times 12 minus 5 equals 2 times 12 plus 7. Let's check each side. 3 times 12 is 36. Minus 5 equals 24 plus 7. 36 minus 5 is 31. 24 plus 7 is 31. There we go. So it's correct. Check. You can check your own work. You see that? Basically, it's the same principles all the time. Whatever you do to one side, you do to the other side. And you need to get x terms on one side by themselves, and everything else on the other side, and then you divide by whatever constant. So for example, let's take this one again. Something similar to, I'll take a picture. Let's say, for example, we have the same one here, right? But this time it's 4x minus 5 equals 2x plus 7, right? Very similar one. But now when we subtract 2x from this side, we get 2x minus 5 equals 7, and 2x equals 12, right? So then we have to just divide by 2, right? So x equals 6. It's the same thing here, but we ended up with something that had a coefficient. So we just divide. You still have to try to get only one x term on this side, and only one constant on this side, and then you can divide through. Right. I'm trying to think here, see if else we might cover. You might have difficulties with. we have 6 plus x minus 1. Sorry? Oh. Something like that. Okay? So first we need to solve this out, right? So this becomes 6 plus 2 times x,
2x
2x, 2 times minus 1,
minus 2.
minus 2 equals 8x.
8x.
Okay. And now we need to add these two, right?
Yeah.
So this becomes
4.
2x plus 4 equals 8x.
Yes.
Alright. And now we need to get x's on each side,
Yes.
right? So here 4 equals 8x minus 2x. So subtracted 2x on each side. Okay? So basically I'm going to move this one over.
Yeah.
Then this is going to be 4 equals 6x.
Yes.
Okay? So then what do?
Divide by 6.
Divide each one by 6. So I want the x.
Yeah.
Right? So whatever the coefficient of the x's, I divide each one by.
Yes.
Okay? So then x equals, what's 4 over 6?
2 over 3.
2 over 3. That's our answer. And if we put it back in here, you'll find it to be true. It might be harder just to do the checking than the solving. It's all the same methods. You simplify it, you isolate x, all the x terms on one side, whichever side is more convenient, and then you divide by the coefficient that's left. Any questions on this? In that case, I'm going to let you go to practice all these problems. Basically, the homework is these 2 pages, 353 and 355. So homework is 53 all and page 355 all. Okay? And you'll notice in the book, we skipped over a unit test. There's like 4 pages here of this test. If you have time, go ahead and do it, and bring up some of the problems if you have any difficulties with them, okay? If not, you can also leave it until as a practice for later. Alright? This is a resource for you. I'm not going to spend too much time doing this because I want to move forward with the course, because I want to get you guys to write an exam. But this is a practice for you.
Yeah.
So if you have time, go ahead and do that and bring up the problems in class, because it'll benefit everybody to go over them. If you don't have time, don't worry about it. Continue with the lesson and do the homework in these 2 pages. And I'll send you some Khan Academy stuff for solving equations as well. And those ones you can just keep practicing and practicing. All right, have a great week.